Hey geometry classes, we're going to move on today. We've talked about our 45, 45, 90 degree triangles, and now we're going to talk about another special right triangle, a 30, 60, 90. Just like in the 45 degree triangle, we got that figure from drawing a diagonal in our square, right, and cutting it in half. So it bisected the angles and cut the square completely in half. And so we found out that there's a pattern when you do that. And we used our Pythagorean theorem to prove what that pattern is. Today we're going to move on and do this with same thing with this equilateral triangle. So how do I know it's an equilateral triangle? I know it because all of my sides are congruent, okay? So what I can do here is talk about what I know about an equilateral triangle. All my sides are congruent, but also all of my angles are congruent. 60 degrees, 60 degrees, and 60 degrees, because I know triangles have 180 degrees total, right? In order to create that 30, 60, 90 right triangle, I have to create a right triangle, right? So I'm going to create that right triangle by drawing a height line from my vertex to my base here. So what did I do with my side here? I cut it in half, right? So these are cut in half. I bisected it, okay? So I'm going to call this X, right? And this is called X. Well, if this is called X and this is called X, I know that this side is both of those X's put together. So I'm going to call it 2X. Now we're going to use our Pythagorean theorem to prove what this third side is. But we didn't only bisect the side. When we drew that line, we bisected the angle up here too. So it's 30 degrees and 30 degrees. I like to prove it using the Pythagorean theorem. That way you know where the pattern came from, right? And you don't think we just pulled it out of the air. This actually matches the Pythagorean theorem pretty perfectly. So if you ever forget the pattern, you can use the Pythagorean theorem if you know two sides, right? So let's look at this. I already know two sides, so I'm going to think about this with my highlighters. So I'm going to say the green side here is 2x. The pink side, the short side, is x. And the long side, so I like to call those those names. So I'm going to call this just helps us remember, because sometimes I get them mixed up, which is the long side, which is supposed to be X and which is supposed to be the other one. So pink is short side. Oh, I didn't do it long enough. This is long side. The orange is long side, and the green is hypotenuse. If you want to get your colors out and do this on your paper, you're more than welcome to. Sometimes adding color is not only fun, but it helps you to remember. So let's use our Pythagorean theorem to solve. My x value is x squared. I'm going to call this b. So we're going to call it b squared, and we're solving for b here, equals 2x squared. And I put parentheses because I have to square the whole thing. So let's solve for b. X squared plus b squared equals 4x squared. I'm going to subtract my x squared here. So I have b squared equals 3x squared. Now remember what we did in our Pythagorean theorem. How do we solve for b? What's the opposite of squaring something? It's taking the square root, right? So I have b equals the square root of 3x squared. Now let's simplify. This is the same as saying square root of 3 times square root of x squared, right? There's not a square root of 3, so it's completely simplified, but I can simplify that because what happens when you square something that's being square rooted? It pops out, right? So we're going to call this x times the square root of 3, right? So my long side here is x times the square root of 3. I'm going to put it right here, but we're also going to do some colors here. Alright, so my long side was orange, and your long side is always across from your 60 degree. Think if you're comparing the lengths across from 60 degrees and across from 30 degrees, that 60 degrees is going to be larger, right? The opening is going to be larger. So that value is x root 3. Across from your 30 degrees is your short side, right? Opening is smaller. We call that x. And then across from my 90 degrees is always my hypotenuse. It's the longest side. It's 2x. So that's our pattern for today. And you'll kind of see as we need to focus this a little bit. There we go. You'll kind of see as we move on what that looks like. Just like we did 45 degrees, we're going to plug in our values first and then solve for x, and then we'll plug it in to solve for the other value if we need to. And you'll see a pattern as we go, because this kind of gets tricky with the x third. Oh, little tip, this is how I remembered it when I was in high school. I always remember that x root 3 is always next to the 30 degrees. It's always adjacent to that angle. Maybe that helps. All right, let's look at our first example. I'm looking for LM and NMN. So I'm going to think about, okay, how do my pattern values plug in here? Well, I know that this is my short side, so I'm going to call that x. My long side is x root 3, and my hypotenuse is 2x. So I'm going to use the value that I know. So remember we said label first, then we set up the equation or formula, and then we're going to solve, right? That's what we talked about our very first day. So I'm going to say 14 equals 2x and solve for x here. So I'm going to divide by 2 and x equals 7. Alright, so if x equals 7, then I know that this equals 7, right? And what about here? All I have to do is plug back in. So our number 4 here, we're going to say plug in, right? After you solve, then we're going to plug in. So this value, I'm just going to plug in that 7 there, and I get a 7 root 3. So let's look here. LM, so segment LM or side LM is 7 root 3, and segment MN is 7. Okay, so you can kind of see the pattern. Half and then times root 3, right? So we have, or you can say double and then times root 3. Those are our side links. So you can kind of see the pattern, right? All right, let's flip it over and try another one. This one's a little tricky. It has a radical that goes with it. All right, let me think about my triangle again. 60, 30, 90. So I have 2x for my hypotenuse, x for my short side, x root 3 for my long side. So let's plug that in. This is my short side, it's x. My long side is x root 3, and my hypotenuse is 2x. All the time, that's the pattern. It never changes, right? Your triangle might flip and turn, but the pattern never changes. All right, so let's see. Let's see the equation. Set up the equation. Oh, well, it's already solved for us. X equals 2 root 5, right? So now I'm going to plug it in. That's my step 4. So if I have 2x and I'm going to plug in 2 root 5, I'm just going to multiply here. So I have 4 root 5, right? Double this one. And here I'm going to plug in again 2 root 5, and then I have a root 3. Okay, well, what do we do with those? Just like here, if it's outside of the radical, you can multiply them. If it's inside of the radical, you can multiply them. So it's 2 root 15. So we've solved already. So here I want us to think. I have 2 root 5, here's my lengths, okay? 4 root 5, that's my hypotenuse, and 2 root 15, that's the long side. So let's answer here. LM, that's the long side, 2 root 15. LN, that's my hypotenuse, that's 4 root 5. So you can see double times root 3, right? Double times root 3. So x, 2x, x root 3. All right, let's move on to the next one. We'll keep going. This one's a little trickier. We're going to have to rationalize our denominator. Fun times. All right, so let's see. My short side is x, right? My long side is x root 3, and my hypotenuse is 2x. So I need to set up my equation. X root 3 equals 8. Now let's solve. Ugh, this is going to be yucky, isn't it? Divide by root 3. Cancels there. X equals 8 divided by root 3. Remember our math rule, you can't have any radicals in the denominator, so we have to rationalize. We have to multiply by a form of 1 that gets rid of that denominator, so it looks exactly the same. You multiply by what you want to get rid of. So what do I have on the top? I have 8 root 3 on the top, and I have square root of 9 on the bottom. Keep simplifying there. 8 root 3 and 3, because the square root of 9 is 3. It's kind of ugly, isn't it? But that's okay. So that's my x value. And now I'm going to plug it in. 8 root 3 divided by 3. And now I'm going to plug it in here. 2 times 8 root 3 divided by 3. When I'm multiplying here, think of this as a fraction over 1 if it's a whole number. And we get 16 root 3 divided by 3. So let's think about our side lengths. 8 root 3 over 3, or divided by 3. Hypotenuse is 16 root 3 over 3. And our long side is 8. So x, 2x, x root 3. So you can kind of see the pattern. These are a little bit more difficult than the 45/45s because on the other one you had two sides the same, so not as much work. Let's plug in here. Ln, my hypotenuse, 16 root 3 divided by 3. Mn, 8 root 3 divided by 3. A little bit of funky work. All right, let's do our last one. Then we're going to work on some together in class. So if you're still having issues, please come to class. That's the most important thing. All right, let's plug in our pattern. Our x value is our short side. Long side is x root 3. Hypotenuse is 2x. We're going to take our known value and create that equation. 4 root 3 equals 2x. Solve. So remember, label, right? These are our steps. These are going to be our steps throughout the semester. Label, then we're going to write our equation or use our formula. We're going to solve. Last step, plug in. Okay, do that same thing. So we're in the middle of dividing by 2. Sorry, I stopped. X equals, if it's outside the radical, we can deal with those numbers. 2 root 3. All right, that's not too bad. Plug in. So this is 2 root 3, and I got to plug in here too. 2 root 3 times root 3. Remember, if it's outside, you can deal with those. If it's inside, you can deal with those. So it's 2 root 9. This is going to simplify very nicely, and we get a 6. So square root of 9 is 3, and then we multiply it by that 2, we get 6. All right. So we have, our side lengths are 2 root 3. Then we had 4 root 3. Are you seeing the pattern? It kind of helps see the pattern if I write it next to each other. So this is x, this is 2x, and this is x root 3. You can kind of see how it goes, right? So LM here is 6. M in here is 2 root 3. All right, so I want you to be prepared because we're going to have a quiz over this. And this is the biggest part of our test. So just be prepared. If you have any questions, come to class and ask those, please. This is the hardest part of the year. It gets easier after this. So make it through special right triangles, and then we're going to go on to trigonometry, and then it'll get a little bit easier, okay? So I want to give you some hope there. This is like the mountain, all right? And after we get through the mountain, then it'll be great. So I'll see you in class. Happy learning here.